R2 is going to be in Ospf 250 area. R3, R4, R5 is in area 1000. And R5 is also in area 0. So we can see here that area 250 is not connected directly to backbone. If that is the case, then there won't be any routes from area 250 learnt in area 0, nor in area 5000, nor in area 1000. Even router 4 will not be learning about the networks coming from router 2. The networks from router 2 will be available only on router 3 because router 3 is also a member of 250. So because there is no area backbone in between area 250 and area 1000, because there is no backbone area in between, routes cannot be distributed from area 250 to other area and vice versa. What does it mean? Even area 1000 routes won't go to router 2. Area 1000, area 0, area 500. None of those routes will be available in router 2. We want it to be in same autonomous system, but to become a part of same autonomous system, it needs connection to area 0. That's what we are trying to figure out. We want this to be yeah, never mind, it's the same story even then. Even if you connect to router 2 or router 3 or router 4, what change it? What does it changes? I don't understand. We don't have different autonomous system. How do you call router 2 as a different autonomous system? Tell me. What makes Ospf autonomous system? If you don't have area 0, you will not have another autonomous system. If router 2 is not connected to area 0, if it is only area 250, how can it be an autonomous system? It's just an area, single area. Autonomous system is collection of non-backbone area and a backbone area. Where is the backbone area for router 2? Why you are not talking? Huh? Hmm. Hmm. What is the point you are trying to make? Make it clear, please. Why you want it to? My aim is to make it as a part of same autonomous system. What is the concept you are trying to achieve by making it as different autonomous system? Tell me that. We are trying to learn virtual link, which we learned in the previous class. This class is a demo for the virtual link, right? Now, why should I put it in different autonomous system if I want to teach virtual link? Tell me. What is the advantage of me? Yeah. So, if we are not forming a virtual connection between R3 and R5, R2 will not, R2 routes will not be able to get distributed to other areas. So connecting to area 0 is important. So we are not going to redistribute here. If you redistribute only, then R3 becomes ASBR. We are not trying to redistribute. We have R3 and R2 in same area 250. Route interface F00, IP OSPF1 area 250. And then I'll go to router 2, interface range loopback 0 to 15 maybe, IP OSPF1 area 250, interface F0/1 also the same. Show IP OSPF interface brief. Okay, good. I'm seeing OSPF running on almost all the loopbacks and the physical. I'm expecting neighbor between R3 and R2. Show IP OSPF neighbor. It's in a two-way state. Extract state, full state. Okay. Now we can see that router 2 cannot find any route in the routing table. See, there is no route in the routing table, even though router 3 is a neighbor. Even though router 3 is identified as a neighbor with this router 2, router 3, even its neighbor, there is no route given. Router 3 cannot give. Router 3, even though it's a member of area 250 and 1000, router 3 has got no power to take the routes of area 1000 and give it to 250 or the other way. So if I go to router 4 and show you, there won't be any routes coming from R2. You cannot see 1.1.1.1 or 23 network anywhere. Router 3 is not showing any routes from R2. Show IP OSPF database. You can see the database showing type 3 LSA is the one which comes from other area, summary LSA, in which you don't see 11111, 1111, 112, 2131, nothing. So if you now try pinging from R2 to R8, ping won't happen. Ping A.A.1.1, no ping, because there is no route. Even router 8 can't ping router 2. There is no route in the routing table for 11111. So we want to form a virtual link between R3 and R5. For that, I need to know the router ID of R3 first. Show IP OSPF. In the first line, you will see the router ID. This is the router ID of router 3. Likewise, you should know the router ID of router 5. This is 55555. So I'll go to router 5 first. Router OSPF1. Listen carefully. I want area 1000 to appear as a virtual link. The virtual link is still that router whose router ID is this. Likewise, go to router 3 and say area 1000 is a virtual link. Now you will see a new neighborship adjacency via virtual link 0. Look at this. You got a neighbor called 55555. Router 3 has got formed, it has formed neighbor directly via virtual link 0. You can also verify by typing show IP OSP of neighbor. You see the first line. Yeah, it's forming full adjacency. Now if I go to router 4, earlier in the database you don't see 1111, but now you should see. Look at this. The summary LSA has got these routes. Very recently came, that's why the age is only 43 seconds. Now if I go and ping from router 2, the ping will happen. And also from router 8, the ping will happen. There's a route in the routing table now, and ping also should happen. So we have not done any redistribution, so R3 cannot be called as an ASBR here. In case if I would have redistributed, then R3 would have become what? ASBR. But you cannot redistribute, you see. You cannot redistribute because it's not two OSPF running on R3. Only one OSPF. Only one OSPF. How you will redistribute? This is the only solution. Virtual link. Or take a connection and make give a direct connection between R3 and R5. That's another solution. So if you are running only one OSPF on R3 and you want R2 also to be in OSPF, then redistribution cannot be a solution. Redistribution is only between two protocols. If you have two OSPF, then you could have done redistribution. I said this is one autonomous system. So why will I go for two OSPF? Any question on this virtual link? So now R3 is also seen as an ABR router. Show IP OSPF. You can see here is a member of, sorry, I'm checking in R8. I want to show you in R3. You can see here it is also a backbone, and that backbone is via the virtual link that he created. Alright, see it's a member of area 250, it's a member of area 1 and 1000, and also it's a member of backbone. And the backbone is via the virtual link. Show IPOSPF interface brief again. You can see virtual link 0 is a member of area 0. Did you see that? It says area 0. Question, please. Do you have any question? Question. You all belong to same process ID. It's not 2 OSPF. So you can't redistribute. from 250 to 1000. To do Ospf adjacency, I would like to take fresh topology. I just want two routers to show you the Ospf adjacency states. I'm going to connect a serial cable between these two routers. And also I'm going to have some loopbacks. And on the other side, done. And now in between we are going to have a network. This is what the interface name that we have in between. It is serial. Now I got the consoles. As they are getting ready, I'll use a notepad. Enable interface loopback 0 IP address. Interface serial 6/0. Instead of putting 24, I have put 14. Right, so end write memory. But I would like to keep this S6/0 in a shutdown state. I'll paste this on R1. Alright, now what I'm going to do is I'm going to start the Wireshark before I enable OSPF. It's a very interesting tool. At least, we should know this Wireshark tool very well. It's actually a entry level tool, but this itself, can give you a lot of information. Not many knows about it. You see, Already created some profiles here. OSPF stub, router without stub, not so stubby area. I got some profiles also created here. Anyhow, let me create a profile now. New profile. I'll add OSPF profile. Right. So far no packets because the interfaces are in a shutdown state. See, do you see the profile name OSPF here? And you see all those things that was there here gone now. I'm going to change the profile. The default profile has got OSPF stub and SSA. I don't want to go with the default one. I want a new one. Okay, now let us go and enable OSPF. Enabling OSPF is IP OSPF 1 area 0. Alright. So let me paste this on router 1 first. And also on router 2. And you can see there's nothing behind the screen in the Wireshark because the interfaces are still down. I'm going to bring the interface up, enable config T, interface serial 6/0 on both the routers. I'm going to say debug IP OSPF adjacency and also show me all the OSPF events. And then I'll go under interface serial 6/0 and say no shutdown. I'm not hitting enter now because I want to say debug here also. Debug IP OSPF events, debug IP OSPF adjacency. Right now I'll go under interface serial 6/0. No shut, hit enter, done. Now behind you can see CDP is first going and the hello package, so everything is over, and you can also see the neighbor state change to full. Now from now on you will see the hello packets will be going and coming. I would like to stop this capture. It's no more needed for me. Now before we go to the Wireshark, I want to show you here the debug. Stop the debug, view all, and debug all on either side. Then I would like to go to the top and show you you can see a two-way state. It means hello is coming from router 3, means router 1. Hello is coming from router 1 with the neighbor address, so it becomes two-way communication to 1.3.3.3. So I should have, I'll try to show you init state in this router. Received hello. So Unfortunately, init is not captured. So after 2A is what? The Xstart state. Xstart state is the place where they decide the master and say, look at this. This router 2 is having bigger IP address, so it says we are not slave, we are master. Whereas router 1 says, under the Xstart state, if you go, router 1 says we are the slaves. So the one who is claiming to be a master will send the DBD first, and then the receive here also it sends DBD followed by that master, and that is what we call as exchange state. After exchange state, you see link state request is going and link state updates are coming, received, which we called as loading state. Even here you can see LSR, updates and LSU. Oh, after that there is no more LSA, LSR, so they reach to full state, loading to full state. You can see that on either side. I'm going to show you these things on the screen at the back. You see, this is the hello packet. Go down and see here. I can zoom it for you. This field, if you don't want, yeah, see here, 224.0.0.5. That's a multicast address. And this is hello packet. Packet type is 1. Now I would like to make this label as hello, and the filter option is converse apply the filter selected. Okay, so if you see, I have clicked on hello, only the hello packets will be listed here. It's a filter that I created for this Wireshark. You don't see any other packet. All the hellos, if you see, the destination address are multicast. Hello packets are sent to a multicast address. Ospf hello packets are sent to multicast address. And Ospf version 4. You see the protocol number is 89. Ospf IGP 89. That's the protocol number. 88 is the EIGRP, 89 is Ospf. And if you see the time to leave of the packet is just 1. So it won't go more than 1 hop. Right? It's the same image, similar information you'll see everywhere. Done. What is next is, let me remove the filter so that I can show you all. We have seen hello. Now let us go to DBD, the database description. DBD under OSPF, if you see DBD, it is message type 2. I'm also going to apply this to a filter. So the next time when we do the OSPF lab, I'll simply click those filters to see. Done. You see hello packets, DBD packets. Hello packets, DBD packets. Now DBD is also multicast. DBD is also a multicast. LSDB is what called as DBD, not LSR. LSR will come later. This is not LSR. Now, after DBD, if you see, you will see LSR, link state request. Here in our case, all the LSRs and LSUs are multicast, but in a non-broadcast, in a broadcast environment, it will be even unicast. Because it is point to point, it is using only the multicast to send the update and request. Instead of serial, if I would have had Ethernet, repeating again, see in serial you can use multicast because you don't have more than one person there. Whether you use unicast or multicast, it is going to go to that one person. But in a broadcast environment, you will have many connected via a switch, many neighbor. So you need to respond to the one who sent you LSR, not to everyone. So there unicast will be seen. Here it is multicast. So LSU, let's check one LSU. LSU is type 4, message type 4. I'm adding it to filter. Okay, this is LSU. LSU is type 4. I think I need to now go to LSR. LSR is type 3. Alright, so there are two LSRs. Now let us see what is carried inside LSR. Link state request is carrying. See, it is sourced from actually, listen, it is sourced from where? It is sourced from the router 1. Router 1 is asking about the link status of router 2. 2.3.3.3 is who? Router 2 is loopback. It is asking to router 2 some clarification. Yep, so that's LSR. LSU will be the response to it. So let's go to LSU. If you see the LSU coming from router 2, update packet, LSU type 1 response is coming. See, it is giving information. You will not understand what it is. Let's check some value and all. Okay, anyway, it says the loopbacks have got these IP address with this as a subnet mask and the metric. It's an update. So hello packets, DBD, LSU, LSR, and now I want to show you the acknowledgement packets. LSAC, here it is. This is type 5. So this is LSA, this is LSR, LSU, DBD, hello. Link state acknowledgement. It's an acknowledgement, period. There is nothing big. It's an acknowledgement. I can give different colors for this. Fonts and colors. We can change color here, but right now I'm not going to do that. It takes I need some more time to figure out this changing color. Anyway, this is not Wireshark class. So I showed you now the adjacency states between two point-to-point routers. So I'll encourage you to do a broadcast. Instead of serial wire, you connect a Ethernet wire. And you do exactly what I do with a Wireshark. Try doing it. And you will see the LSRs and LSUs will be unicast, not the multicast as I see. Sometimes, yeah, it is multicast if an update is common for all the broadcast members, but you will also see some of them are unicast. Yeah. Right. Welcome.